What were the deadliest natural forces on Earth? And how did they reshape human history? We're counting down the top 5 largest natural disasters by death toll, from millions lost to tens of thousands. Our planet, for all its beauty and life-giving properties, possesses an immense and sometimes terrifying power. For millennia, humanity has lived alongside these forces, often bearing witness to their awesome and destructive capabilities. From the shifting of tectonic plates deep beneath our feet to the fury of overflowing rivers, we begin our journey in the heart of China in the year 1931. Here, along the basins of the Great Yangtze Yellow River, nature conspired to create a catastrophe of biblical proportions. The stage was set by years of unusual weather patterns, prolonged drought, winter snows. When spring arrived, the meltwater surged into the river systems. Then summer brought 7 cyclonic storms. The sheer volume of water was simply staggering, an assault the rivers could not contain. The rivers, arteries of life, became agents of destruction. The Yangtze, the long river, swelled to unimaginable levels. In places it rose over 16 meters, 53 feet, above normal. Centuries of dikes and levees were overwhelmed. One by one they failed, unleashing silt-laden water across an area the size of England. Entire villages vanished beneath the waves. Survivors clung to rooftops and debris, crowded into boats and makeshift rafts. The initial floods killed hundreds of thousands by drowning, but disease followed. Dysentery, cholera, typhoid fever. The stagnant waters and cramped camps multiplied suffering. When waters slowly receded, they left ruin. Farmland buried under thick silt, useless for years. Harvests collapsed, and famine followed. Infrastructure was obliterated. Millions were homeless. National and international relief efforts struggled to cope. Estimates of the final death toll vary, from 1 million to almost 4 million people. It is arguably the deadliest natural disaster of the 20th century. The flood is a stark lesson in extreme weather, human engineering, and the power of great river systems. Managing rivers needs more than walls. It requires a watershed approach, from the distant mountains to the sea. It highlighted catastrophic deforestation in the upper reaches, increased erosion and runoff, and the limits of aging dikes. Those lessons would shape modern flood management worldwide. We travel back just a few decades to 1887 and to another of China's great rivers. The Yellow River, or Huanghe, is the cradle of Chinese civilization, its fertile silt nurturing agriculture for millennia. But it is also known as China's Sorrow, a name earned through a long and tragic history of devastating floods. For centuries, the river has been engaged in a constant battle with the people living along its banks. A battle that, in 1887, humanity would lose in a spectacular and horrifying fashion. The fundamental problem of the Yellow River is sediment. It carries an enormous load of fine yellow silt, eroded from the Loess Plateau upstream. Over time, this silt settles on the riverbed, gradually raising it higher and higher. To contain the river, farmers and engineers built dikes along its banks. But as the riverbed rose, the dikes had to be built ever higher. In a perilous feat of engineering, the river was eventually flowing not through a valley, but on a raised aqueduct of its own making, several meters above the surrounding floodplain. In the autumn of 1887, after days of exceptionally heavy rainfall, the inevitable happened. The immense pressure of the floodwaters found a weakness in the dikes near the city of Huayuancu in Henan province. The levees failed. It was not a gradual overflow, but a cataclysmic breach. An immense wall of water, carrying the pent-up energy of the elevated river, burst forth and cascaded onto the low-lying plains below. The landscape, flat and densely populated, offered no resistance. The water spread with astonishing speed, fanning out to create a vast inland sea. It covered an estimated 13,000 square kilometers, an area comparable to the size of Connecticut. The force of the deluge completely altered the river's course, with the main channel shifting hundreds of kilometers to the south. For the farmers living on the plains, there was no warning and no escape. The flood swept through countless villages, erasing them from the map in a matter of hours. The immediate death toll from drowning was immense, but as with the 1931 floods, the suffering was far from over. The survivors faced a world utterly destroyed. With their homes, crops, and food stores gone, they were plunged into a devastating famine. The floodwaters lingered for months, preventing any new crops from being planted and creating the perfect conditions for the spread of deadly waterborne diseases. Drowning, starvation, pestilence. The final death count is, once again, difficult to ascertain with precision, but historical estimates place it somewhere between 900,000 and a staggering 2 million people. The 1887 flood was a brutal lesson in the dangers of relying on aging infrastructure to contain a dynamic and powerful natural force. It demonstrated that simply building walls higher is not a sustainable solution when the fundamental mechanics of a river system are working against you. The tragedy of China's sorrow was a stark reminder that sometimes the very solutions we create to protect ourselves can inadvertently set the stage for an even greater catastrophe. Chapter 3. Our journey now takes us further back in time to the Ming Dynasty in China and deep into the earth itself. On the 23rd of January, 1556, the ground beneath Shanxi province began to shake, and its neighbors began to shake. This was not merely a tremor. It was a cataclysm that would be recorded in history as the deadliest earthquake ever known. The event, now referred to as the Jiajing Great Earthquake, struck in the middle of the night, a moment of maximum vulnerability for the sleeping population. The epicenter was in the Wei River Valley, a densely populated region. While modern seismographs did not exist, geologists today estimate its magnitude at around 8 on the Richter scale. But the sheer magnitude alone does not explain the immense death toll. The true tragedy lay in a combination of the quake's power and the way people lived. Much of the population in this region resided in yaodongs, artificial caves carved into the soft Loess cliffs. These cave dwellings, warm in winter and cool in summer, had been a practical housing solution for centuries. But against the violent, rolling waves of a major earthquake, they became death traps. The soft, porous earth simply liquefied and collapsed, burying entire families and communities alive in an instant. There was no structure to hold, no doorway to stand in. There was only the sudden, suffocating darkness as tons of earth entombed them. The destruction was not limited to the cave dwellings. In cities like Huaxian, the epicentral town, it is reported that every single building was flattened. Massive stone city walls, temples, government buildings crumbled into rubble. Contemporary accounts describe 60-foot deep fissures opening in the earth. The shaking was so severe that it was felt in provinces hundreds of kilometers away, and it triggered landslides that buried yet more villages under an avalanche of rock and soil. The official annals of the Ming Dynasty recorded the grim statistics. They meticulously listed the death toll, province by province. The final horrifying number is estimated to be around 830,000 people. It is a figure that strains belief, representing a significant percentage of the entire region's population at the time. The immediate aftermath was a scene of utter chaos, with survivors struggling to find loved ones amidst the ruins and aftershocks continuing to terrorize them for months. The Shanxi earthquake serves as a profound lesson in seismic risk and building resilience. It tragically illustrates that the deadliness of an earthquake is not just a function of its power, but is intimately linked to population density and construction methods. The event also highlights the limitations of our historical records. While the chronicles provide a shocking death toll, the personal stories of the millions affected are largely lost to time. It is a silent testament to a night of unimaginable terror, when the very ground people trusted turned against them with lethal force. Chapter 4. We now leap forward to our own time, to an event witnessed by the entire world in shocking detail. On the 26th of December, 2004, deep beneath the Indian Ocean off the west coast of northern Sumatra, the planet shuddered. A massive section of the Earth's crust, where the Indian plate slides beneath the Burma plate, ruptured. The fault line stretched for over 1,000 kilometers. This was a megathrust earthquake. The energy it released was staggering, equivalent to 23,000 atomic bombs. The quake measured between 9.1 and 9.3, the third largest ever recorded. It caused the entire planet to vibrate by as much as 1 centimeter. But the immediate shaking was only the prelude. The seabed suddenly and violently uplifted by several meters in places, displacing a colossal volume of water. An immense, almost imperceptible swell of energy radiated outwards across the Indian Ocean at jetliner speeds. In the deep ocean, the tsunami was barely noticeable, a long, low wave under ships. Approaching shallow coastal waters, its character changed dramatically. Energy compressed into a smaller depth as the wave slowed and reared up into a monstrous wall of water. Indonesia, Thailand, Sri Lanka, India, and a dozen other nations, there was no warning of what was about to arrive. The wave struck with merciless, indiscriminate power. It did not break like normal surf. It surged and churned. It was filled with debris, trees, cars, fragments of buildings. It scoured land clean, reaching kilometers inland in flat areas. Tourist resorts, fishing villages, entire cities were obliterated in minutes. Aceh province, closest to the epicenter, suffered the worst devastation. The human toll was overwhelming and international. An estimated 230,000 to 280,000 people lost their lives, swept away or crushed by debris. They were people from all walks of life, local fishermen, families in their homes, tourists from around the globe who had come to enjoy the beautiful beaches. The aftermath on countless cameras showed mud, rubble, and widespread loss broadcast worldwide. The 2004 tsunami was a brutal wake-up call. It exposed the lack of an Indian Ocean tsunami warning system, unlike the Pacific. The disaster catalyzed an international effort to build networks of seismographs and deep ocean buoys, DART. It taught critical lessons: coastal preparedness, public education, and global cooperation. Chapter 5. For our final and perhaps most globally significant disaster, we journey to the island of Sumbawa in modern-day Indonesia. Here, in April of 1815, stood the mighty volcano, Mount Tambora. For 1,000 years it had lain dormant, but deep within, pressure was building to an explosive crescendo. On the 10th of April, it unleashed its fury. It was the most powerful volcanic eruption in recorded human history, a 7 on the Volcanic Explosivity Index. The eruption was apocalyptic. It ejected an estimated 160 cubic kilometers of pulverized rock, ash, and gas into the atmosphere, creating a plume that reached an altitude of over 40 kilometers deep into the stratosphere. The sound of the explosion was heard more than 2,000 kilometers away. On the island of Sumbawa itself, the devastation was absolute. Pyroclastic flows, superheated avalanches of gas and rock, raced down the volcano's flanks at hundreds of kilometers per hour, incinerating everything in their path. The local kingdom of Tambora was completely wiped from existence. The local kingdom of Pekot was also destroyed. The immediate death toll from the eruption and the resulting tsunamis was estimated at around 11,000 people. But this was merely the prelude to a much larger, global catastrophe. The sheer volume of fine ash and sulfur dioxide injected into the stratosphere was the critical factor. These aerosols formed a veil that encircled the globe, reflecting a portion of the sun's radiation back into space and causing a significant drop in global temperatures. The world was about to experience a volcanic winter. The following year, 1816, became known in the Northern Hemisphere as the Year Without a Summer. New England experienced snow and hard frosts in June, in July, and in August, killing off newly planted crops. In Europe, the relentless cold and rain led to catastrophic harvest failures. Rivers flooded and the price of grain skyrocketed, leading to widespread famine, riots, and social unrest across the continent. The weather was not just bad, it was fundamentally broken. The indirect death toll from the Tambora eruption is where the true scale of the disaster lies. The subsequent years of famine and disease, particularly the outbreak of a new strain of cholera in Asia that was likely exacerbated by the climate disruption, claimed tens of thousands more lives. The total number of fatalities directly and indirectly caused by the eruption is estimated to be at least 71,000, and perhaps significantly more, making it the deadliest volcanic event in recorded history. Mount Tambora's eruption is our most powerful lesson on the interconnectedness of Earth's systems. It demonstrates how a single, localized geological event can have profound and lasting consequences for the entire global climate and for human societies thousands of miles away. It forced a nascent scientific community to begin to grapple with the concept of climate forcing and deep time, and it even left its mark on our culture, with the gloomy summer of 1816 inspiring Mary Shelley to write her Gothic masterpiece, Frankenstein. Outro. From the drowned plains of China to the ash-covered fields of Europe. These were not acts of malice, but the inexorable workings of geology and climate. These disasters changed millions of lives. Preparedness, infrastructure, global response. The stories of the Shanxi earthquake and the Yaodong caves teach us that how we build can be as important as where we build. The great floods of the Yellow and Yangtze rivers underscore the awesome responsibility of managing the world's great waterways. The eruption of Tambora revealed the fragile, interconnected nature of our global climate, showing how an event on one side of the world can bring famine to the other. And in our own century, the Indian Ocean tsunami was a brutal but effective catalyst, forcing the international community to cooperate and build the warning systems that will save countless lives in the future. Each catastrophe, for all its horror, left behind a lesson, a piece of knowledge paid for at the highest possible price. They are a humbling reminder of nature's supremacy and our place within it. As we continue to build our world, we must carry these stories with us. They compel us to innovate, to study our planet more deeply, and to prepare for the inevitable challenges ahead. For while we cannot stop the Earth from shaking or the volcanoes from erupting, we can learn to listen to their warnings, to respect their power, and to build a more resilient future for all of humanity. Thank you for joining me on this journey through some of the most powerful moments in our planet's history.